Welcome, guys. Welcome to the people in the room, the very, very full room.
Hello.
Welcome. Hello. And a good morning to you. Welcome to people on the live stream. Welcome to people watching later.
Yeah.
I want to thank you very much for getting up after the party so early in the morning and standing in line.
Who had trouble getting up this morning? My hand's still up.
Yeah, that was tough. So I guess we should introduce ourselves. I'm Mads Torgersen. I am on the C#, VB, and F# team as a PM working on the C# language.
He's too humble. He actually writes the C# spec, right?
Are we going to out-humble each other, Dustin?
We may. My name is Dustin Campbell. I'm a program manager on the Managed Languages team, mostly responsible for editing experiences, the IDE experiences for C# and VB, and for the past 4 or 5 years, exclusively working on Project Roslyn.
Yeah, and he's too humble as well. He's the heart and soul of Roslyn, really. So today we are going to talk about the future of C#, because it has one, and actually, I just want to stress right now, VB also has one, and everything we say applies to VB as well. We're just going to mostly show it in terms of C#. So if anyone was worried, stop worrying right now. In the big mall map of things we've been talking about, .NET related at Build, we are sort of in the basement, in the dungeons. The core stuff, right? We're going to talk about, obviously, language, compilers, IDE experiences, the core stuff. And the context for all of this is what we have been referring to lovingly for 4 years or so as Project Roslyn, which is a long-term thing. We've been on re-implementing our compilers, for C# and VB compilers, from scratch in C# and VB. C# and VB C#. No, the other way around. And implementing them in such a way that they have rich APIs that we can publicize that are high fidelity, efficient, resilient, immutable, any kind of hipster word you can look up in the dictionary, APIs we're going to offer to give you deep insight into source code, the deep insight that we have, that we use in our IDEs and so on. We put it all on CodePlex yesterday. Some of you may have seen Anders press the button in the keynote. It's all live up there. If you want to see the code, mess with it, contribute to it, you can do so. Yeah. And the core component here, the compilers and the APIs, we refer to now as the .NET Compiler Platform because it's kind of a platform for compilers. And going forward, we are going to, this is going to be the core of everything we do with C# and VB.
Absolutely. Absolutely. It's funny, right? I mean, I was talking with some guys over here, too. The open source thing came as a surprise to some people, right? But when we look back at our design notes and goes, oh, what was the beginning of this project like? Back in June of 2009, I dug up some of the very first design notes and that listed the goals where we're just trying to, what are we trying to do here? And open source was on it, right? So it's always been on our minds. And so this is kind of a really big coming home moment, this build.
Yeah, this is a great opportunity to engage. And I kind of want to go into why do you embark on completely rewriting a huge, big thing that's complicated enough as it is? Well, I think there are several audiences that this is good for. Obviously, there's millions of developers out there who, because of Roslyn, can now get a richer IDE experience. We built, and you can already see in the previews we've handed out, we built a much more deep and sort of language-savvy IDE experience on top, and all on top of a public API, right? We only use the public API to the compilers. We don't have any backdoors or any special knowledge.
Right.
And because of that, there are thousands of people out there who will probably take Roslyn and build their own little extensions to VS, their own little command line tools and so on that deeply understand the C# and VB source code and do things with it that are specific to your purposes, that are just nifty, that you will share out in a broader ecosystem and so on. So we really hope that there'll be this kind of boost of other people doing the stuff that we could only do before and sharing it out and making the experience better for those millions as well. And obviously there's ourselves. It's become a lot easier to be a developer on the C# and VB team because we have a much nicer code base using languages that we obviously love. And it sort of makes it an order of magnitude easier for us to evolve the languages and,
Yeah, I mean,
and do new features.
like you saw yesterday, right? Anders took 3 small changes and added a string literal, right? And that's kind of a contrived example, right? For a demo, for a keynote on the one hand, but on the other hand, there was actually a feature that was added almost in the same way, right? When they added, when Anthony went in and added VB multi-line string literals,
Yes.
right? Which Visual Basic string literals are only for a single line. They made a multi-line string literals. He literally, literals, literally. That was funny. He just deleted 1 line out of the compiler, and it just worked. Everything worked in the IDE. So some of these things that we've struggled for years to introduce into the languages because they might seem small, turn out to be a much higher cost, now are as cheap as they should be,
Yeah.
right?
So this really removes a big impediment for us to add value, both to the language, to the Roslyn APIs, and to the IDE as we move forward. And not only that, but C# and VB are very, they're not the same code base, but they share an architecture and they share a lot of code. And so the cost of adding a feature to both is not twice, it's like 1.2 times or something like that. So we're really in a good place there. And I think when you think about the open source aspect of it, that really just enhances on all levels, right? It means there are more developers to reach out there. You heard the Xamarin announcement yesterday that they're going to start building on the Roslyn code base as well. We will share the compiler code base with the Xamarin tool stack.
Yeah.
And again, more partners and obviously more people who can play with the code base, add features. Some of them probably will be there'll be pull requests. Some of them might come back to us, and so on. So it's just getting really big. Very nice. All right. So we don't want to show you a lot of slides. We want to show you a lot of code, and we want to start out by showing you giving you a glimpse of some of the IDE experiences we can build on top of Roslyn. We're going to show you, or Dustin is going to show you, how to build that kind of thing yourself with an example. He's going to do a diagnostic right here on stage using the Roslyn APIs. And then in the end, I will dive into some of the language features we've already added because we have this new nice architecture to do so. So, Rustin, show us Duslin.
What? Did you just say that? All right. So I'm going to show you really a piece of Roslyn that is, I would say it's one of the scenarios we're going after is not, it's about being able to download the compiler, tweak on the compiler, and play around with things. That's cool. But what about the compiler that lives in Visual Studio? How can you interact with that? Right? How can you build tools that don't require you to go fork it and do something all on your own? And so one of the ways that we've added to Roslyn, kind of an official thing we've added to Roslyn, is this notion of a diagnostics framework. And diagnostics are essentially the compiler fundamental component that an abstraction for errors and warnings and info messages and things like that come from the compiler. So we're going to look at that. The first thing I want to do, though, is actually acquire it. Well, I'll show you how to acquire it. If you haven't yet, highly recommend you go get Roslyn. And by Roslyn, I mean you can go to the Codeplex site, you can download the source, but also get that end-user preview. The end-user preview has in it, it's a very small preview, but it's kind of amazing in what it does. Often when you get these V6 installers, these extensions, you get them out of the extension manager in Visual Studio, and they tend to do things where they add value or they add features on top of the existing IDE experiences. This one does some pretty scary things, and it completely replaces the IDE experience. So you'll come out here. This is at msdn.com/Roslyn. And you can go get the preview. All right, you fill out a little submission form, and you're taken to a download site. This is just so that we can, get back with you if we have some updates and understand who's using it. So I've already got it down here, and I'm going to install it. So here's the Roslyn end user preview. This is a V6, and it's pretty easy to install. And now it's in Visual Studio.
And now it completely messed up your existing IDE experience forever, right?
Yes. No. It's very easy to disable. So if you have it installed, you need to go roll back. Maybe you've got, you're putting out production stuff, and you want to make sure that you are compiling with the old compilers and not the new compilers, because there's some concerns. You can always disable it, right, and do your build or that sort of thing. But it's really fun to use the new IDE experience. Now, also up there is the SDK preview. Okay, and the SDK preview is for building things that with Roslyn, right? So it gives you a bunch of things like some samples. It gives you project templates, some tools to help you do that. So I'm going to install some project templates into Visual Studio. Again, it's just a V6 installer. And I'm going to install the syntax visualizer, which is a really great tool window for being able to look at Roslyn syntax trees, the parse trees, and understand. Really helpful for when you're trying to write an extension. And then I'm going to run this little exe. And this exe is responsible for setting things up so that you can debug a Visual Studio, a Roslyn extension in Visual Studio. So it kind of sets up a sandbox where Roslyn lives. And so you can, when you press F5 from a Roslyn extension in Visual Studio, it launches another Visual Studio in this sandboxed area. So you're not installing extensions into your main Visual Studio. So I'll double click this. It has an incredible UI. There we go. And we're all set. So how many people were at Jay Schmelzer's session yesterday where he talked about .NET kind of all up and all the investments we're making? He showed an extension in there that I wrote for him, and we're gonna look at how we write that. Okay. But first, I want to look at this application. This is a self-indulgent moment. I'm a self-indulgent sort of guy because this is going to be our fodder code for what we're trying to build. But it's also a really cool application. I built this for TechEd Europe last year. And it's a Z-Machine interpreter. It's not actually an interpreter. It's like a full-on JIT compiler. Somebody applauded for the Z-Machine? Yeah, all right. You know what a Z-Machine is. Z-Machine is a VM from the 80s that was designed by a company called Infocom to run their text adventure games. Okay, and so you can, and they're the company that made Zork. So with this, if I run this, I've got an interpreter here, and I can load up Zork. This is the real Zork, by the way. They put it out publicly available, and I can play it, and there we go. And I can do all the things you can do in Zork, right? We can open our mailbox. This is all we're going to do for the rest of this, by the way.
You're right about self-indulgent.
Read the leaflet. Yeah. Actually, no, you know what's really self-indulgent? I'm kind of a cheater when it comes to games. So I just play it from beginning to end. And at this point, we've killed the thief, we've killed the troll and all that, and we get to the very, very end at about 355 moves. We are now master adventurer, a perfect score, right? So,
hey, dude, Roslyn, okay?
Well, anyways. So this is my demo fodder. I like to use this for demo fodder, just for some code. And the code I want to look at is actually right here. All right? And this code is maybe not doing what you think it's doing. How many people work on a team where they require braces be added on all ifs and elses? Okay, there's a good reason for that, and this is that reason. The reason is that else clause actually belongs to the nested if, but doesn't look like it because it's formatted incorrectly. If you format it, then sure enough, the language service puts it where it actually goes, but it doesn't look like it was doing what it was doing. And so what I want to do is I want to write a diagnostic. You know, the compiler's errors and warnings are surfaced through the IDE. We get all these squiggles, and it's a really useful thing. It seems like, why can't I write those myself? Right? And Roslyn has a framework for doing that, the diagnostic framework. So let's go ahead, and we're going to create a new diagnostic with a code fix. Okay, this is from that Roslyn project template package that I installed earlier. And I will call this brace checker. Now, this talk also, I want to mention, this talk is about the future of C#. This is a big piece of the future of C#. We believe this is going to be a core thing that people do. You can imagine, right now, we're going to build a V6 extension that installs into Visual Studio. But down the road, we expect that these will carry along with projects. Right? You'll be able to carry along a set of analyzers with your project. If you have styles that you want to use, or you have very specific rules that you check on various projects. We also imagine a world where, and we're looking forward to a world where APIs coming through NuGet would also carry analysis along with them so they could help you use the APIs properly. Right? So this is a very core part of what we want the experiences of C# and VB to be going forward as an IDE experience. Okay, so this is some boilerplate. Let me reformat some things so we can see them a little better. So the project template creates a little bit of boilerplate for us. And what it is, it's a symbol analyzer. Okay? This is a diagnostic analyzer that implements an interface called symbol analyzer. And it's exported via MEF, and it runs as the compiler performs its analysis. Okay, so it actually runs inside the compiler. As the compiler is going through and looking at declarations, which turn into symbols, whether they're type or member declarations, as soon as it finds one of these and it's going to put it into the symbol table and mark it as kind of as declared, it says, oh, well, I've got a diagnostic analyzer here. Let me call it as well at that time. So see if it has some analysis it wants to perform, and let me know about any diagnostics that it might find. This one in particular does some pretty simple stuff. Let's just run it. And so I've pressed Control F5. It's going to launch another instance of Visual Studio as soon as it builds. And we should see in here. Come on now. Actually, we'll look at this one. And what it does is it does something very silly. It simply squiggles if it finds any types with lowercase names, right? It's just some goofy little boilerplate. But then it also has a code fix associated with that diagnostic that I can bring up, and it'll make it uppercase, right? You see that it automatically brings up this preview. You can see that it's making the name change everywhere. It's actually doing a real rename, not just changing it there in the code. And so that's pretty cool. That's not exactly what we want to do. We don't want the symbol analyzers work with declarations. We want to get inside method bodies, right? We want to get inside a method body. We want to look at if statements and else clauses and determine whether they have braces or not. And we also want to add a code fix to add the braces. Okay, so we're going to delete some code. All right. And actually, let me go into Code Fix Provider. I'm going to delete some code here too, just so that we're not. And there's a bunch of. It's just this boilerplate that does the rename. But I want to start from scratch, and so we'll return null here. Okay. So instead of iSymbol Analyzer, I want to say iSyntax Node Analyzer. And there's a whole bunch of different kinds of host of these kinds of things. You can actually look them up here, and you can see all sorts of. All sorts of analyzers that perform on at different times in the compiler's processing. We're going to go with Syntax Node Analyzer. And in here, we give it the type of syntax that we're interested in. This is for the language that we're interested in. I'm interested in C# syntax. So I just type syntax kind here. I know there's a C# syntax kind. I can bring up add using for that. And then I can also, and I'm using, by the way, I'm using the Roslyn IDE to implement things, right? These are the same things we've had for years. Add using when you press Control dot, implement interface when you press Control dot. But now we get it as part of this Roslyn experience. We see a preview of what's going to happen with implement interface when we do it. This is all built on the same infrastructure that we're building here to do this brace checking thing. Right? So we're using the same APIs that you'll be. Let me clean this up. All right. So the first thing we need to do is we need to tell it what sorts of syntax we're interested in. We're interested in just two pieces of syntax, and that are else and ifs. But let's take a look at what that looks like. So I'm just going to put some code here so we can look at it. And I'm going to bring up a window that I installed earlier. I installed this Roslyn syntax visualizer. That's super useful. We can bring that up over here. And what this gives us is a way to, let me pin it for us. Gives us a way to, as I move my caret through code, actually see the tree that's there, the Roslyn tree that's under the hood. Okay, in fact, I can come here and I can start clicking on things, and they'll get highlighted in the editor. Right? So this is really useful for understanding what things look like. Okay, what they actually look like in the trees. Because when we build our code fix, we're going to do it in terms of syntax trees, the actual parse trees underneath Roslyn. We're going to transform a tree, say, here's the change I want to make, transform that tree, and then give it back to the code fix engine, and it'll apply it across Visual Studio. So if I want to add braces, you see up there in the Roslyn syntax visualizer, you see the else clause here, right? If I want to add braces, come down, actually do the brace add, and go back over here, and now we see, oh, okay, there's a block inside of it. So what happens is we need to insert that block. That's what we need to do as part of our code fix and part of our transformation, and that's what we need to be detecting. We need to detect, is that block there or not? Okay? All right. So let's actually write some code. First, I need to tell it that I'm interested in if syntax and else clauses. This will give us ensure that we're only called for analysis on those types of syntax nodes. So we don't get called for everything in the world. That would be rather inefficient. Right? We just say, oh, no, we're only interested in being called for if statements and else clauses. OK. Now, my goal here is to show you guys that if you have a team that needs some sort of special kind of style checker, some sort of special thing about your code that you want checked, you can write this. This is really, really mind-numbingly easy to write, OK? When we get in here. We've done our boilerplate. We've got it all set up. And I just want to show you how easy it is. So in our analyze node, we are called with a syntax node. That means, hey, I found, the compiler's going through, it's doing its analysis, says, I found one of these nodes that you were interested in. Do you have anything for us? So we're given a syntax node. We're giving an API called a semantic model, which lets us ask semantic questions about that node if we have any. In our case, it's actually going to be purely syntactic, so we're not going to need to look into that. But it's there for you. It also is passed a callback that you can call to pass in a diagnostic. Wow, I should not use the mouse. Right? So if you have a diagnostic, you can add it with this guy. And then a cancellation token as well. Right? So you'll find that a lot of the Roslyn APIs take cancellation tokens. You can be called asynchronously. That's by design. It's expected, and that's part of the reason why Roslyn has a very immutable model. And when we start looking at these nodes, that node is not going to change out from under us. Right? Everything in Roslyn has an immutable snapshot kind of model. And so when we start going to do our transformations, you can think of it like string.replace, right? Where string is an immutable within the .NET framework in the BCL. And so when you call string.replace, you're giving back a new string, right? It doesn't mutate that string in place. When you work with Roslyn APIs, it's almost exactly the same way. Okay? So the first thing I want to do is I'm going to check and see, was this node an if statement? So we call it if statement syntax is the name of the type. Go ahead and add it using. And again, I'm just using the IDE, right? It works well. So I'd highly recommend trying it out. So, because it could be an if statement or it could be an else clause. So we'll do an as here. And then if it was not null, well, then we need to check. We need to do some checks. Actually, if it's not null and if its statement was not null, right? And one more check. We want to check and say, if its statement's not null and its kind is not a block, right? If it's not a block, then we need a squiggle. It's pretty simple. So I'm going to say if statement, a statement. It's a little redundancy there. Is kind block. All right. And so now I know I'm in a place where I've got an if statement, it's got a statement underneath it, and that statement's not surrounded a block, so I can go ahead and add a diagnostic to it. The diagnostic, we're going to pass in our diagnostic descriptor. Now, that's actually created for us in the boilerplate up here. Let me go ahead. This old boilerplate is wrong. I'm going to go ahead and replace this with something a little more appropriate for our extension, that single embedded statements must be surrounded with braces. And so the rule is created with this metadata. We'll pass that in down here. We're going to give it a location. That's where the diagnostic is going to appear. You can think of it as where the squiggle is going to be. And we should put that on the if keyword itself. Okay? Say if keyword get location. And then one last thing, we need to pass in some message args. These are just format specifiers. It's like string.format. My message up here has this. So I want to say if statements require braces, right? So let's go ahead and put that down here. And we are done with if statements. Let me run it and see if it works. I hope it works.
I hope so, too.
It would be great if it worked.
Yeah.
It would be great if it worked.
Yeah, really hope so.
They would be more impressed if it worked. Boom. So now we have if statements require braces.
Yeah.
Right here and right here. That was easy. It's like 5 lines of code, right? Let's go ahead and add else clauses as well. Looks almost the same. Okay? And so now else clauses are in there. And so if I run this again, you'll see the else squiggle. Okay, let's go look at the code fix. The code fix uses a different layer of the API. Because the diagnostics need to run in the compiler so that they could run not just in the IDE, but they could run at the command line, they could run in your build server. right? They live in the compiler layer and really use fundamental components from the compiler API. When you're writing a code fix, however, you're expected to be a little bit higher level, where the user's interacting with something, maybe inside an editor. And so you get a different set of APIs that let you do more things. One of them is the document that comes in here. This document is part of another API from Roslyn called the Workspace API. It's an immutable snapshot model of solutions, projects, and documents. So you can kind of go at a bigger scale. When you have the compiler, you're just looking at a single instance of running csc.exe or vbc.exe, where you have a set of files, you have a set of references. But with solutions and projects and documents, things get much richer. You have project references and all of that. So we're given a document, we're given a text span, and I'm going to go ahead and insert some code here to first get the syntax root from that document. We're going to do a tree transform here, and I need to get the root of the syntax from the document, which is essentially the root syntax node, make my transformation, then stick it back in the document, and tell it, hey, this is the document you should use for this fix. So I'm going to get the root of that document. Then we're going to get the token that is at the span that was passed in. So that's going to be either the if or the else that we squiggled before. That's what's going to get passed. Then we check and say, oh, was this the if keyword? Right? If so, we know that the parent of that token is going to be the if statement. And then we perform a transformation on it. And again, this is sort of like string.replace, right? So I've got that statement that's part of the if statement syntax we saw in the diagnostic. Here we can say with statement to replace it and get back a new if statement. And the way I replace it by creating a block, and I simply, inside that block, I pass in the old if statement, right? So it kind of surrounds it. Then we go to the root, and here this looks very much like string.replace. We go to the root, we say replace node, we give it the old if statement, the new if statement, we get back a new root. And then we return a code action to add braces. Let's do the same thing for else's. There we go. And it's almost the same code. We could generalize this, but for the sake of time, you'll let me write code that looks like copying and pasting. Control F5. And we should have a code fix now. As soon as things come in, as soon as the analysis happens. And there we go. So now we have a code fix that will go in and add the braces. It doesn't do the greatest job, however. That looks really terrible. Unless do your teams require braces be on the left edge of the... That's awful. If your teams do that, it's wrong. There's also a bug in here. It's not real obvious what that bug is, but it's actually showing it on else's that also contain ifs, on else ifs. We probably don't want that. We don't want to be, making it put braces around the else, around the if, right? So we should probably fix that as well. That's kind of a sucko thing. So we'll go back to the diagnostic analyzer to fix that piece, and that looks like this. We check to say if it's not a block, and we also check to say if it's not an if statement. That fixes that. And then the way we're going to fix the formatting problem is by adding an annotation, by annotating the node that we're creating. There are some well-known annotations. This makes life a lot easier. There are well-known annotations to apply to syntax nodes when you're creating a code fix or a code refactoring in the Roslyn API that will do magical things. And we're going to apply an annotation that tells it, format this node. At the end of when code actions happen, when code fixes and refactorings are applied, there is a formatting step. And it walks through, and it only formats the nodes that actually have this annotation on it. So it doesn't format the whole document, just the pieces that you've said, oh, I've changed this. Please make sure it's applied with the correct formatting. It works does the C# formatting rules for C#, the VB formatting rules if it's VB, and it also respects the user's options that are set in Visual Studio, the ambient options of the host. So if you have your braces set to go on the line before, it'll do that. So that's pretty easy to do. We just say at the very end here, because again, this is immutable, and so we kind of chain things together in that style of programming. We say, at the end of our if statement, we say, oh, with additional annotations, pass in the formatter annotation. And we'll do the same thing down here. And now, when I run this, will ideally be bug-free. I hope it's bug-free, Mads.
I hope so, because you pasted it in.
I totally pasted it in. So if it's not bug-free, then should be very upset with me. So the else is no longer reported here. That's hopeful and expected. And now my code fix does the right thing. It puts the braces in the right spots, right? And there we go. We've written a custom diagnostic. We've written a custom code fix. We did it in 15 minutes. And it's not a lot of work. Again, my goal here is to show you that any of you can go do this, that building with the Roslyn APIs is not just for the language weenies and the geeks, right? Anyone can go and play with these and do really meaningful things for your teams, or just get involved in the ecosystem. That is also part of the future of C# that we're looking at going forward. So
it's
cool.
just an object model, right?
Right.
Like any other thing, and it applies at the level of abstraction where you need to interact with it.
Yeah.
So hopefully you'll feel encouraged to go out and play with this yourselves. Even if you don't think of yourselves as compiler geeks, this is totally doable.
Yeah, cool. All right, Mads.
Yeah.
I think it's, we've had a little bit of IDE talk up here, and
Yeah.
we've looked at the APIs. I'm pretty sure they would like, these guys are here to look at language features.
No.
Oh, no.
Okay, a little. Yeah.
Maybe a little bit.
All right.
Didn't sound very
Maybe I should
enthusiastic.
switch over here. Yeah, I think they're, yeah.
All right.
Maybe they need to be woken up a little.
I can do some interpretive dance.
Okay, so you get to see
I
me
am a syntax tree.
You get to see me log in. Nice. Tree pose. So we're back in the on the landing page, the MSDN homepage here. Dustin took you through the acquisition of the previews. Let us actually go and have a quick look at the CodePlex site as well. I'm not going to do any actual open source manipulation up here like Anders did, but let's just have a quick look around. If we look at the documentation tab here, for instance, you'll see that there are language design notes for C# and VB. Lucian, Wishik, and I have started to fill those in. The sort of just our internal design notes from the last year or so, we've gotten part of the way. We'll get further. You can go in here and click and see all the thoughts we had, unedited and embarrassing as they are, as we were designing these language features, and we'll keep posting new ones as we meet and evolve. So that, I mean, for some of you, that might be fun reading. And you can go in, these are just forum posts. You can go in and comment on things and give us good ideas if we have trouble coming up with the right syntax or whatever. I think that's going to be a fun interaction.
Yeah, I think that this is kind of a cool thing that, you know, this is going to be kind of a cool thing that we are now not just interacting open source and developing in the open. It's not just, you know, kind of an ivory tower sort of situation where we're in this dome, but you can actually come and be involved in language design as well.
Right.
That's a really exciting feature.
It's a great sort of just immediate feedback and interaction kind of loop. So I hope you'll enjoy that. Now, what we are actually doing for language design so far, let me first of all, let me state right out that language design this time around is a sideshow to Roslyn, right? We're spending our resources, and the big features, those are Roslyn level. Those are about the APIs and the new IDE and so on. But the fact that it's gotten so cheap for us to do language features, it kind of feels like too good of an opportunity to pass up. We've had, over several releases, we've had this feeling where we came up with some really big features, and then we only ever got around to doing those. And we feel we have a backlog of wanting to do smaller features that are just helpful, remove boilerplate, maybe take us in a more declarative direction with the language like we started on with LINQ a couple of releases ago. And so that's the kind of approach we're taking. No big stuff in the language, at least we haven't come up with some yet. And some of those features that we thought of are now in the preview. And we intend to keep adding a few more before we get to the release. And you can follow our thoughts about that on the CodePlex site. Most of these features apply equally well to C# and VB. Some of them are specific to one language because of peculiarities in that language or the other one. And some of them are just catch-up features where the other language already had it. So let's have a look around. Let's first take a little bit of a look at VB. I promised there would be a little bit of VB in here. Check. One of the things that's really annoying to VB developers is not being able to put comments on every line here if there's a line continuation thing. And of course, we just enabled that now. It's one of those things that's really easy to do once you have the Roslyn code.
Yeah, that one actually came completely for free.
We didn't do anything.
It just worked.
We just decided not to turn it off, essentially.
Yeah.
So actually, it's not just an order of magnitude easier. It's actually negative work sometimes to do a feature. Another one that's just a quick slam dunk is multi-line string literals that Dustin mentioned. Didn't have that in VB before. Again, came almost for free. Actually, we just removed the restriction.
There was a delete key.
Yeah, we removed the restriction that we first put in. So if we thought of it before, it would have been negative work as well. So there are a few of those where VB is just catching up to some C# features. Then there are things that are uniquely VB. VB has a great expressive select case statement, unlike C# switch, which is a little kind of stuck in C, C++, kind of very limited. And that means that you can, in VB case statements, we already have sort of a good variety of conditions you can put on a value that's being selected on. And we decided to add the ability to switch on case as well, so, or in type as well. So you can take the value and say, if it has this type, for instance, the shape here, if it's a circle, give it a name that has that stronger type, and use that in the case here. And so you get a very nice type casing syntax going on, and where you're just essentially free from doing a lot of ifs and type checks manually yourself. I think that's going to be really cool. We wish we could do something like that in C#, but we have to think more about it because it doesn't fit in so well with the language. You'll also notice here there's a when part that you can put on. You can put extra conditions on your selections that are arbitrary Boolean expressions as well. So this one is a really nice VB-only feature. Also, both C# and VB, so features that we are adding to both. There's some we only got around to implement in VB so far. They will show up in C#. Binary literals, OK. The brotherhood of hex, why do we really all need to kind of mentally map hexadecimal to bit patterns? Why not just let you put the bit patterns in there? And then we also, yeah?
We did it for you, sir.
This is one of those that was suggested to us by the community as well. It's like, yeah, why do we not have binary literals? We'll have them in both languages. And also, especially with binary literals, but in general, when literals get big, it's nice to be able to separate the digits. We went with the underbar for C# and VB, and there's also a few experimental other characters that you can use in VB. We'll probably remove some of them. So if you want to play with it, now's the time. I'm not going to say what they are. It's kind of you can go and see if you can find out. So that was VB. Now let me switch to C#, and here I have some code that I haven't actually used new features in yet, and we're going to go through and apply some. So so I have a little program here. It creates some points. I don't know if you've heard Anders' talk about TypeScript on Wednesday. He also embarrassingly used the point as an example. And,
I thought that was just a language designer thing. I thought you guys had to.
That's because we really only test language features on point. Right? I don't know, maybe you get the impression that some of the same people were involved in these languages. So I'll make some of the same points that Anders made here. And print them out with a helper function, turn them into JSON using Newtonsoft's JSON.net here. Turn those into strings, print them out, turn them back into JSON from the string here, and then back into points and print them out. So it's really just, I'm going to run this just once. And so it's really just using a JSON library on some data type that I constructed, or that I'm constructing here. The first feature, Anders showed a little language feature in the keynote, the using static. It is, let's use system.console. So now I can use, if I could spell, I can use a type here instead of a namespace, and that brings, come on, that brings the static members of this static type directly into scope. VB already has this feature. You can see that it's grayed out. Rosalind nicely grays it out for me because I'm not actually taking advantage of this using. But I'm going to. If we click down here, we can see that there's a nice suggestion for a code fix here that I go and simplify the type and not actually call console.writeLine, but just writeLine. And it's a fix all occurrences here with a preview, nicely Roslynized. And if I go and select that, I can now just say writeLine. You know, similar system.math and things like that. You'd probably use that pretty often. So that's a simple little catch-up feature. Let's let's move away from our main program here and our use things and look at the point class itself. One of the things, as I mentioned, we're interested in getting rid of boilerplate and helping you get rid of boilerplate. And we kind of want to take a declarative, immutability supporting kind of tack on it. One of the things that's really annoying, I think, we talked about the Roslyn APIs being immutable. It's really great. It's, you can throw a bunch of concurrency at it. You don't have to worry that somebody else is modifying the data that you're looking at if it's immutable. That's a really good pattern. And in C# and VB, we have been punishing you whenever you use that pattern, right? We have auto properties that are getter setter properties that automatically have a backing field. But you have to have a setter, so they have to be mutable, so they don't work for immutable code. We have object initializers, but they work only on mutable code and so on. And we kind of want to level the playing field and make declaration of immutable types easier, even as we make declaration of all types hopefully easier. So let me show you a few features that will take all this boilerplate here, the private fields, the constructor, the properties, and kind of boil that down and reduce it. That's sort of the first set of features I'm going to work on. So one thing particularly nasty here is just having this big constructor that does absolutely trivial things. So we're going to add what we call primary constructors. So far, that's a C# only feature. We're thinking about how to fit that into VB as well. So we will let you put constructor parameters directly on the class instead, and that generates a constructor for you under the hood. So let's remove this constructor here. And it puts the parameters into scope for initialization. So I can go and initialize my privates with them like this. And I essentially now have the effect of that whole constructor that I had before. All right? So primary constructor. Thank you.
Mads, just to be clear, I just wanted to check. You don't have like a custom private build on your machine or anything, right?
No, this is a preview.
This is just the Roslyn preview. OK, so they can use this.
They can use this, though not in production, right?
Not in production.
Not in production.
You can play with it, yes.
So this is just, I mean, you can follow along if you have it installed. Sit there and follow along on your laptops or your fancy touch devices. So, or your Xboxes. So that's one thing. I still have these privates. It's really nice with mutable types. It's really nice to, if I'm not doing anything special in my constructor, it's nice to use auto properties that just automatically allocate the backing field, if you will. Let's say, if X here was an auto property, then we're also adding the ability to initialize auto properties. So I could instead have an auto property. Thank you. This is going to be good, Dustin.
Yeah, I think they like this.
And initialize it directly. And this doesn't actually call the setter. It directly initializes the underlying field. Well, why do we only have auto properties with setters? Well, that's because otherwise, how would you get a value into it in the first place? But now you have a way to get a value into it in the first place. And so we can actually now allow getter-only auto properties that have the backing field initialized like this. And so not only do we not punish you anymore for being getter-only, we kind of give you a 4 or 5 character advantage. Who's keeping score? But still. So this is pretty nice. We can get rid now of the private field here, and we're getting to something that's really terse. And of course, we could do the same thing with Y here. But let's also talk about the situation where you have a parameter that you don't just want to expose through an auto property. Maybe you have more logic you want to put in the getter or something like that. Or maybe you want to keep that property, you want to keep that parameter private for something else. And not expose it directly in a property. So there you still need a private that's declared elsewhere and keep your sort of your getter logic here. Let's say we want to do something really important with it before we expose it. Like, the unary plus. So another thing we want to do for this scenario here is we want to help you not have to write this private in this case either. So we want to let you declare an accessibility modifier directly on the parameter. And what that says to the compiler is declare that parameter and also declare a field with that accessibility and automatically generate the code that initializes the field with the parameter. Okay, so this declares a private field on the type called y, as well as that constructor parameter initializes it too. You can also, once you do that, you can also use other modifiers that you can put on a field, and they just go on that field that gets generated. And so now I can delete this guy and directly use the y field inside of my body here. Again, just a way to reduce some of the boilerplate and have you do less declarations. So you're getting to something that's pretty terse and pretty readable here. That's what we're trying to achieve. We may still have a few more additions to come in this space, but again, so far, primary constructors to let you put constructor parameters directly on a class, initializers for auto properties, getter-only auto properties, and field parameters, as we call them. Those should get you a good long way of the way. Whether you are writing mutable types or in general, just a lot of your types could probably get a number of lines shorter if you go through and apply this stuff. Okay? So let's move on and have a look inside of the two static helper methods I have. I have a to-JSON and a from-JSON method that are for that conversion that you saw before. I take an IEnumerable of points here, and I turn them into a JArray. Or I take a JArray, and I turn it into an IEnumerable of points. The first thing to notice is there's something wrong with my code here. Oh, Dustin's thing is running here. So
yeah.
let's see if it works. Add braces. Oh, that looks kind of good. Let's do that. All right, cool. Because I live in a corporate environment where we decided to have these formatting rules,
yes.
And they're just enforced by something Dustin whipped up during a talk recently. So it's very nice. What I want to point out here is a few things. I talked about declarative again. If you remember some of the things we did when we introduced LINQ, they were about doing more things in expressions, not showing the how in terms of modifications of intermediate state, but showing the what, the structure, right? And what I'm doing here is creating a J object, a JSON object that has an X and a Y on it. Okay, I have to do that with the string indexer because those aren't really members. They are just they look like members, X and Y fields, but really they're just like something in an indexer. And for that reason, I can't use an object initializer to initialize them. If they were real members, I could say x equals p.x and so on. But because they are indexes, well, I can't do that. Well, except we're adding a feature so you can. So now we have what we call dictionary initializers on object initializers where you can initialize to a specific index. Okay? So this becomes valid syntax, meaning that now I get to create and initialize my J object in one expression, which is kind of what you want. Especially for something like JSON that's structured, you want to have that ability to just write one expression that creates a hierarchical structured object, and now you can do that. It's kind of fun to chase this declarativeness down a little. I may go over the top here, but please indulge me. I now notice since I don't really need the local variable there anymore, right? I can just go and add it directly because I'm not modifying it anymore. And now I'm adding it directly. This sort of starts looking like something maybe you could express with a LINQ query because everything's just done in one expression. So let's comment this thing out and let's go and see. JArray has a constructor that takes an IEnumerable of something. So let's go and actually just put a LINQ query in here instead that creates all the J objects to put in the JArray. So from P and points, we want to weed out the null, so where P isn't null, the ain't operator. And we just select, let's see, what do we have down here? We select this expression. Now it's one expression, so I can just put it in a select clause. And there we go. That was it. Wow, nice. So actually, we just return that thing directly and get rid of all this other stuff. And wow, that starts looking very declarative. Things are just being created structurally, very link-like. And so taking the next step down the link road here. And actually, there's a new feature that we're planning to add that we haven't added yet. I just want to tell you about it, too, which is that actually when you have one of these methods that has just a single return statement with an expression, like if it was a lambda, you could just have an expression body instead of a statement body. And we want to add that to methods as well. So you could like just say, actually, we will use the fat arrow and just say, oh, hang on. Just say this and get rid of this guy. And so you could do that too. That's probably going way too far. And you see I get red squigglies because we haven't implemented it yet. But that's the kind of thing we're thinking of. For simpler things, for sure. Oh, took me a step too far there. So let's look at the other method as well here, the one that goes the other way. Another thing I want to point out is, yes, it got nicer with those indices, but it still doesn't feel like we think of them morally as members, but it doesn't feel like we're working with members. And so we want to you could go, if you wanted to work with these guys as members, you can go and implement dynamic and use the dynamic feature for that. That's already in the language, but that's pretty heavy-handed, right? Then you have to cast your J object to dynamic in order to interact down here, in order to to dot into X instead of indexing into it. There's nothing you could do up here where you're creating it, because there's no way to create and initialize dynamic objects like this with the current feature. It's hard for the guy who has to implement dynamic on the J object, so the guy actually went and did it, but it's a whole lot of boilerplate code. And especially at runtime, if you think about running on small client devices and so on, dynamic is a really heavyweight feature at runtime. It runs half the compiler, and it generates code at runtime and so on. It's really not, this is not the sweet spot for the dynamic feature, especially on resource-constrained devices. So we want something much, much simpler. And what we boiled on this for a long while, and what we essentially came down to is we want to make it look like a member access, but it doesn't have to be exactly like a member access. It should be something with dot, but it's OK if you put another glyph in there. Okay? So we want to say, if you can sort of talk about $X as an indexed member or a pseudo member, if you will. And if you dot with one of those, that really just turns into calling an indexer with a string literal. It's really just that. Like, this is really just syntactic sugar for that. That's all it is. But it kind of feels nicer when the thing you're working with is morally an object. Say JSON, XML, obviously, CSV files, all that kind of stuff. You kind of want to just make it look like dot. And we also support that syntax up here in the object initializer. So you can say $X equals that, and $Y equals that. And that means exactly the same thing. It's just a little shorthand. Okay. So that's one. You like it? Good. I mean, it's a really small feature. It's really just syntactic sugar. I don't know how many lines of code it was in Roslyn, but we can do this stuff now, and we're doing it. So one last thing I want to point out that's already also in your preview there is another nuisance, another place where you feel like you're forced to use statements, even if you would rather not, is when you're calling methods without parameters. You have to declare variables first and then pass them in, because out parameters have to be variables. And that's just a nuisance. Now, here I have an if statement. I'm only using X and Y inside of the if statement, but I have to declare them on the outside because I'm using them in a condition and so on. This is just annoying. So we're saying, OK, let's introduce a thing called declaration expressions, where you can declare a variable anywhere as an expression, instead of just as a declaration statement here. Let's get rid of this, and let's declare X right here where I'm using it the first time. So I'm just saying int X right here. It declares the variable X, passes it as an out parameter, and also puts it in scope for some value of the surrounding environment. And we have reasonably sensible scope rules around this, so that X is actually in scope down here in the body of the if, as well as where it's declared in the condition. OK, so I can do the same. Hello, mouse, where are you? I can do the same thing for Y. And obviously, these are like declaration statements. You can initialize these guys if you want to. If you initialize them, you can use var because we can infer the type from the initializer. And actually, if you're passing them as out parameters, and it's obvious to the compiler which overload you're calling, you don't actually even have to initialize them to use var, because it'll just go and look at that overload and see, well, what's the type here? It expects an int. Let's just infer int for the var here. So I'm not saving a lot of characters for int here, but if it was a big generic type, this is going to be nice too, right? So now I declare x and y, and I just use them in here. And again, we get to this very declarative spot. I declare variables as I use them, and we could actually go and turn this method into a LINQ query as well. That's a little over the top. I'm not going to have you watch me type it, but I'm going to actually show it to you just to you know. I was going to, hello, Toolbox, come on. Toolbox seems to have forgotten my, Toolbox has forgotten my, OK, I'm going to skip that. But the point being that, once again, because I can do this condition inside of, I can declare these variables inside of an expression. Places like LINQ queries, you can now declare variables and use them in the same expression, even though you're not in a statement context. And that comes in really handy. That's it for what I was going to show directly. I want to quickly mention a few more features that are in there that are super useful. Await. For some reason, we thought when we built async that it was really hard or possibly impossible and not meaningful at all to have awaits inside of catch blocks and inside of finally blocks. We just didn't think we could do it because, I don't know, some kind of syndrome. But, or we were really busy.
We were exhausted.
We were really busy and exhausted for implementing it in the native code base that we had.
Yeah.
And so now we went ahead and allowed it inside of catch and finally blocks. And that is actually really useful. How many times have you wanted to asynchronously log an exception in a catch block, or wanted to close something up in the finally block that required an async call, and you couldn't await it in there, so when you got out of the finally, you didn't know if you were done yet, and now that works. And it's horrendous to implement, but it's actually efficient and nice code. It's just like, it's our heads explode, and that's how it should be, so that your heads don't explode. I also want to mention quickly exception filters. You know, VB has them, F# has them. Now C# has them too. That's all I'm going to say.
Nice.
And that's pretty much what I'm going to show. Watch out for more language features. Give us feedback. Play with it. All that kind of stuff. All right?
Yeah. So we're getting very much to the end here. And what you've seen here today, this is the future of C#, and it is bright. We can do language features. Go back to that pyramid we had up earlier, because I've had a lot of people ask me over the years, why would I use Roslyn? Everybody's going to use Roslyn, right? It's going to be your compiler. You're going to get language features on top of it that we can build now because of Roslyn. You're going to get IDE experiences, so everybody will use Roslyn. And I hope we tempted some of you to go off and maybe try playing with the APIs a little bit. And so as a call to action, install the previews. Try them out. Actually, you know, they help us. We've got a lot of telemetry built in there. It'll help us make the product better. We want to make sure we get performance tuned just right. We get everything working really well. So that will also help us. Dip your toes in, right, with the diagnostics. If you're really ambitious, consider forking the compiler source and you know, playing around. There are already in the realm of 25 forks, official forks, created the source code since yesterday. So definitely go try and do that. Here are some other resources. One thing we haven't pointed out that's really cool, if you want to check it out, is that fourth one down on the left, on the links, the Roslyn source browser. If you're familiar with the reference source we put up for the BCL, there's also one up of Roslyn now. So you can poke around through the source code. It's got clickable links where you can find all references and all that sort of thing. So, but anyways, with that, thank you guys very much. It's been a treat. And we've got like 53 seconds, which is probably a little too short to do official questions.
We can take, let's take one or two questions.
Yep. No, yeah. they're saying no. So
they're saying no?
We'll be up here and you know, tearing down.
Yeah.
We can walk out with you and have some chats. If you guys have some conversation, we'd love to talk to you.
Thanks for coming.